Yes, I'm still here.
Okay. What is acceleration?
The rate at which an object's velocity changes over time.
Okay, that's perfect. Change in velocity over time. Rendani, how are you?
I'm good, and you, sir?
I am good, thanks. I was trying to get hold of Makadzi as well, but I couldn't. I wonder.
Maybe she's studying because tomorrow we're writing maths.
You're writing maths. Oh, okay. Okay, yeah, no problems. But are you ready for the maths lesson so far?
For the maths lessons or for the maths test?
Sorry, for the maths test. Sorry, yes.
Oh, partially. Partially. I just have to
Partially.
do trigonometry graphs and then revise everything.
Oh, yes. Okay, no, that's perfect. So I just want to ask quick questions, Rendani. What is the area under the velocity time graph?
Oh, thanks. The area under the velocity time graph.
Yes. The area under the velocity time graph.
Acceleration.
It is
Acceleration.
acceleration. Perfect. Okay. What is the area under the acceleration time graph?
Acceleration time graph.
Hmm.
Velocity.
Velocity.
Yes.
Yes, that's correct. Okay. What is the let me see. Okay, the slope under the displacement time graph.
Slope under the displacement time graph.
Yeah, the slope of the displacement time graph, sorry.
It's is it still acceleration?
Kumisa, do you agree with the acceleration?
What was the question?
Huh?
May you please ask the question?
Oh, the slope of the displacement time graph.
Is it velocity?
That's correct. That is correct. Because the slope is most change in displacement over time. That is acceleration. Sorry, that is velocity. Like I said, that is velocity. That's perfect. Let me come up with another example. But Randani, do you understand?
Yes, sir.
Okay, perfect. No problem. We're gonna do another set of a graph. I want you guys to get used to the graphs. And also on the example that I gave you, the one I gave you on WhatsApp yesterday, did you get it? Randan,
Yes.
the graphical example. Okay, can we, before I do the one you are seeing on the screen, let us try to tackle that one.
Okay.
Okay. Let me see if I have it. Okay, just give me 1 minute. I just want to send it to myself. and see. Okay. Okay, let me check it. Okay, just want to check it on the internet first. Maybe it's there. Okay, no, it's not. Okay, let me just open it on WhatsApp and send it to myself. Okay, share. Share on Rendani, what is the slope of the velocity time graph?
Area. Sorry. The slope of the velocity time graph acceleration.
Yes, that's correct. Okay. What is the slope of the voltage resistance graph? The slope of the voltage resistance graph. Rendan.
Charge.
Kumisa, do you agree? The slope of the voltage resistance graph. Rendan, remember that is voltage divided by resistance. Does it give you charge?
No.
What does it give you? Because that is the slope. So what does it give you?
Oh, no, it's not charge.
It can't be charged.
Wait, can you wait?
Can be charged. The slope is V of voltage divided by resistance. Voltage divided by resistance will give you Kumisa from Ohm's law. Current, exactly. This thing is easy. Rendan, you are looking for current. Because if you go to your formula sheet, you know very well that I equals V over R. So the graph part is V over R, which is the slope. V divided by R, this is the slope. Okay. Now, if I rearrange and I have, sorry, this is I, okay? So what is the area under the current resistance graph? Rendan.
Voltage.
Voltage, that's correct. This is the graphical part. On this example, this is your graphical part. Okay, perfect. So it's the same thing that we're going to be doing on this one. So You have a velocity time graph. And the first question was, Rendan, what was the first question? Calculate acceleration.
Yes.
Okay.
I said A is equal to.
Okay. Acceleration A is equals to?
Change in velocity over
change in velocity divided by?
Change in time.
Change in time. Perfect.
Yes.
From there?
I said 55 minus 0 over 30 minus 0.
55 minus 0 over the change in time, 30 minus 0, which gave you?
It ended up as 55 over 30, which gave me 1.83 meters per second.
1.83. 1.83 meters per second. Kumisa, do you agree with that? Okay, Kumisa, what is the alternative? Kumisa?
So what are we looking for?
For acceleration. Using the graphical approach, how are you going to approach this one? Acceleration. How do you calculate acceleration given a velocity time graph?
I think I agree with 1.83.
Oh, you agree. But do you agree with, because when you are given a graph, usually they are looking for you to have an understanding of what a slope of the graph is and what the area of the graph is. So acceleration is the slope of the velocity time graph. Whenever they give you a graph, usually that's what they are looking for. You need to use the terminology of areas under the graph or the slope of the graph. The slope of the graph is, let's say, for instance, you can pick any coordinate. Okay, let's see. Okay, so if you are saying this is 55, I'm okay with it. So this will be 30, 55. Okay, that's fine. You can use 54 or 55, but let's stick with 55 for now. That's coordinate number 1. And then another coordinate is 0.0. You can use any. The slope of the graph will be change in y divided by change in x, which is 55 minus 0 divided by 30 minus 0, and it will give you 1.83. So I'm gonna emphasize and overemphasize. Whenever you get a graph in your exams, they want you to be able to, they want you to be able to understand the relationship between acceleration, velocity, and displacement using the terms slope or an area under the graphs. Under the graphs. So the second question says, what is the displacement between 10 to 20 seconds? A displacement between 10 to 20. Ten to 20 seconds. Rendani, how are you gonna go about it? Okay, let me go up.
To calculate the displacement.
Yes. The displacement.
Okay, I wait. What I did was confusing.
What did you do?
So, let me see. The area of, oh no, the displacement, right?
Yes.
I started by calculating the area under the graph
Okay.
between 10 and 20 seconds, right?
Yes.
And there's a trapezium. So,
Mm-hmm.
I said area is equals to,
Okay. Area. So first of all, we know that the displacement equals area and the velocity time graph. You must state that in the exam. That's 1 mark. Okay. Then from there,
okay, area is equals to a half
half
times
times, let's go up.
AD plus BC in
A,
brackets.
okay, AD. You just said AD, right?
Yes, AD. No, you see, at school they taught us that, you see, usually because it's a trapezium, we'd have to first split it into, like, you see, the triangle and the rectangle, right?
Yeah.
But the teacher said that it's a long process and it would bring us back if we said a half of the sum of the parallel sides times the.
Oh, yeah, I know the one you are saying. Okay, so it's AB plus,
BC.
it's not BC, it's
I-
EC.
Yes.
But I asked Makazi and she said she doesn't know the formula of calculating the area of a trapezium. That's why I had to break it down.
Oh.
Yeah, but it's fine. So yes, this is the area. So this is equals to 1/2 into AD is what?
1/2. AD is 35 meters per second.
35.
Wait, let me check. AD. Yes, 35.
This is A, ne? You agree?
Hmm.
And this is D.
Yes.
How is it 35?
I said 10 plus 15 plus 20.
Sure.
Oh.
Yeah, but I'm glad you made that mistake now before you get into the exam. It's fine. No, the distance from A to D, you just come and subtract 30 minus 10.
Oh,
Yes.
30 minus 10.
Which is
It's 20.
no, not 30 minus 10, sorry. 20 minus 10. That's the distance between 10 and 20. 20 minus 10. How
It's
much are you getting?
10.
You are getting 10.
Mm.
And then AB, again, we're going to do the same thing. So that will be, what is AB, Rendan?
We're still going to say, wait, 10 minus, 30 minus, 20 minus what again?
It's not entirely 20, it's here.
20.
18.
18, right?
Yeah.
18 minus 10.
Hey, minus 10. This is B.
Oh.
You're talking about this distance. From here to there, it is 18 minus 0.
Oh, yes.
If
Yes.
you're traveling from 0 to 18, you're going to travel 18 steps. So that's what we are looking for. Don't get confused. 18 plus AC will be, okay, let me go up.
10. Huh?
EC, yes. What will it be?
EC.
Yeah.
Oh, EC. It's 10.
Yes. Yo, why are you getting all these things wrong? Because
I'm
E,
confused.
this is E, you agree?
Okay. Oh, okay. From B to E.
No, EC, from here to here. Agree, this is a trapezium.
Mm.
You are adding this length plus this one, and then you divide by 2. And then
36.
no, not for now. Yeah, okay. What is the distance from C to E? How much did you get?
C to E, right?
Yeah,
36
that's
minus
correct. 36 minus,
0.
yes, which is 36.
Mm.
Okay. If you use your calculator, how much are you getting?
Right? I have times 10 times 18 plus 36. 270 meters per
270.
Mm.
The
I got
units?
meters.
Meters. Okay. So, oh, you wanted to say something. What was it?
Oh yes, my answer was 250 meters. So I feel like the formula I was using it's not wrong, but my substitution was wrong.
Yes. Yes. Because I know possibly you have tried to use the equation of motion,
Yes.
which is not a problem. Let us use the equation of motion. Alternatively, you do have V initial, which is equals to at this point, it is equals to 18 meters per second. 18 meters per second. You agree?
Yes.
Okay. Then you also have change in T, which is 20 minus 10, which is 10 seconds. You agree? You also have V final, which is how much?
Wait. Oh,
V final.
V final is 36.
36. Perfect. Okay, so if you are using the equation of motion, which formula were you gonna use?
If I was using the
Equations of motion, which formula were you gonna use? If you have all these parameters, which equation of motion were you gonna use? Let me drag the equations of motion.
and yes, displacement is equal to V final minus V initial.
Let me copy it first, ne?
Oh, yes.
It's fine. Okay. And I'm gonna paste it at the end. Then we will use it from there. Okay. These are the equations of motion. Let me put them properly. Yeah, perfect. So which equation were you gonna use?
I was going to use the second equation.
Okay, perfect. So whenever you're in the exam, you just need to think about these four formulas. Pick the right one and that's it. That's how easy this thing is. And you are right. So you have your V final plus V initial all over 2 times change in time. Okay, so this will be V final is 36 plus 18 divided by 2 times the change in time is 10. So if you use your calculator, how much are you getting?
270. Oh, okay.
You see? Do you see how easy this thing is? Yeah, so this thing is very easy. Kumisa, do you have any question?
No, sir.
Okay, perfect. Now let us do more graphical questions now. That's what we're gonna have. Let's see. Okay. A velocity versus time graph below illustrate the motion of an object that is initially traveling east. At t0 second, the position of the object is 0. The question is, what is the velocity of the object at t0? Kumisa. What is the velocity of the object at t0? At t0, what is the velocity? Okay, Rendani, what is the velocity at t equals 0 seconds? Rendani?
Oh, sorry. The velocity of the object, right?
Yes.
At t, which is 0 seconds. 10, isn't it? No. Is it 10 meters per second?
You are right. Yes. You are right. In the start of the motion, this is t0. The velocity was 10. You are right. 10 meters per second. Perfect. Kumisa, describe the motion of the object between A and B. Can you describe the motion between A and B? We have two scenarios. Scenario A, B, and B, C, then C, D. Now, between A and B, Kumisa, can you describe the motion?
The object goes 3 seconds east.
3 seconds. Remember, when you are describing the motion, you have to describe the velocity. What is happening to the velocity? Kumisa?
10 meters per second of velocity goes 3 seconds east.
All right, the object, Rendani, do you have any take? Rendani? Do you have any take? Rendani, what is your approach on this question?
Oh, sorry,
Describe,
I could
describe
myself.
the motion of the object between A and B.
I was going to say, right? I'm not sure about it. I was going to say, from A to B, the velocity remains constant at 10 meters per second moving towards the east.
Yes, that's what I was looking for. The word constant, the object was moving at a constant velocity eastwards for 3 seconds. For 3 seconds, okay? And then 5.1.3, calculate the acceleration of the object for the interval B, D. So the object started moving at a constant velocity of 10 meters per second from A to B. Then it changes the velocity, as you can see on the graph. Now, 5.1.3 says, calculate the acceleration of the object between B and D. Kumisa, how are you gonna go about this one? 5.1.3, the acceleration. Kumisa?
A is equals to the change of t divided by the change of v. The change of v
Acceleration equals change in v over the change in t. Okay, correct? From there, Kumisa?
negative 10 divided by 5.
Okay. So you are saying v final is equals to negative 10 meters per second. Yes. Okay, that's fine. That's what I'm gonna write. Negative 10 to Misa.
Divided by 5 seconds.
Divided by let me go up. You said divided by 5 seconds.
Yes, sir.
Okay. So this is minus 2 meters per second square. Rendani, do you agree with that?
Wait. For 5.1.3.
Yes.
Oh, I still at that one.
Do you agree with that?
Yes.
You agree with the answer?
Wait. Yeah. Not okay. Yes, I do. But okay, yes, I do. I agree.
I don't.
Yeah, you see what I did, ne?
Mm-hmm.
I said I used the formula for A is equals to change in velocity over time taken.
Yes. This one.
Yes.
Okay.
And then I said negative yes, negative 20 meters. Negative 20 over 5.
Negative 20 over
5
okay. Where did you get the negative 20?
from the, go back to the graph, please.
Okay.
I got the negative, oh, sorry, negative 10.
Okay. Said negative 10. Okay.
And then,
Negative 10.
yeah.
A
Oh, no,
negative 10 divided by 5. That's what you're saying, right?
it's, and then we'd get
Negative 2.
negative, oh, yes, negative 2. Can we
Okay.
also,
Can we also?
oh, no, we can't.
Okay.
Yes.
Again, I'm going to emphasize and overemphasize this. Whenever they give you a graph, so let me emphasize and overemphasize. Whenever they give you a graph in physics, usually they want you to use the graph, the principles of graphs, which I've been teaching you guys for almost 2 days. Okay, it's fine. Acceleration is the slope of the graph. Kumisa, do you agree with that?
Yes, sir.
Okay. Now, there's 2 scenarios. We will forget about the first scenario. It has nothing to do with the question. We're going to focus on this scenario. In whatever we're going to be doing, we will focus only on this scenario. Scenario A, scenario B, D. Forget about A, B. Okay. Thus, what is the slope of the graph in this section? Because that's what we are being asked for. BD, section BD. Kumisa, what is the slope of that section? What is the slope of that section? If you want to find the slope, you need to determine the coordinates. What is the slope of that section? Kumisa. Kumisa, do you see any coordinate that you can pick on this graph? This section of the graph. Rendani,
Sure.
oh, do you have any coordinates that you can see on the graph? On this portion of the graph. That's what we are focusing on. Do you have any coordinate that you can see?
On that portion,
Yes.
the AB portion, right? Or the trapezium.
BD. We are only focusing on section BD from here to there. Only. This one you forget. Do you see any coordinates that you can pinpoint?
Yes.
Okay, Rendani.
10 and 3. The coordinate of B is 10 and 3.
10,3.
Yes. And then the coordinates of C.
I disagree with you. You can't say 10,3 because with coordinates, you must start with the x-axis, not the y-axis. I'm sorry. 3 and 10. Perfect. Do you have any other coordinate that you can see?
Yes.
Okay.
You can also see 0 and 5.
0 and...
Hey, 0 and 5. 0 and 5. Wait.
No,
5 and 0.
5 and 0. Yes. Any other coordinate?
Yes, coordinate D is 7 and negative 10.
7 and negative 10. Others you can extrapolate, but I'm not very interested that much. But it's fine. Do you see this one?
Yes.
Okay. Now let us find the slope. Brendan.
Oh, she find the slope.
Yes.
We can say change in time over change in velocity over change in time,
Yes.
which would be, we can use maybe 10 minus negative 10, the coordinates of D and B. You can say,
Okay. So it is 10 minus negative 10 divided by...
can we please go up again? Which 10 minus negative, oh yes, divided by 3 minus 7.
Okay, perfect. 3 minus 7. So how much are you getting?
5. Negative 5. Yes.
Negative 5. Do you see the difference between your answers and the one you just got now?
Oh, okay, yes. Yes.
Whatever you got up there, it's rubbish. You guys are not using the principles of graphs. And that's a problem. And the other thing is, I heard you guys are trying to use these short formulas. I don't like using these formulas. I want you to always use the equations of motions. You will never go wrong. You will never go, okay, using the equations of motion, I am going to forget about scenario A, B again, and then I will just focus on this scenario. So in this scenario, my velocity, what is my velocity initial? Rendan, in this scenario B, D, what is the velocity initial?
Initial. It's going to be 10.
It is going to be 10.
Yes.
Then velocity final?
It's going to be negative 10.
Negative 10. And then you do have the change in time, don't you?
Yes.
It is going to be how much?
Oh, wait. 1, 2, 3, 5 seconds.
5 seconds. So why is it 5 seconds? Velocity final is 7, right?
Oh, yes.
Minus no, not velocity, sorry. The time initial time final is 7, and the time initial was from this point only. It was
3.
3. So this will give you
4.
okay. Now, if you consider the equations of motion above, let me show you where they are. Okay, let me copy and paste again. Copy and paste. Okay. Which equation of motion were you gonna use? Rendan.
If what? If we're looking for?
If you were to calculate acceleration,
Yeah. Wait. Oh, which equation of motion here were we gonna use?
yes,
V is equals to VO plus AT. I'm thinking that one.
the first one. Okay, perfect. So what you are gonna have is V final equals V initial plus acceleration times change in time. You agree?
Yes.
Actually, let me rub off this one. Okay, so V final equals V initial plus acceleration times change in time. Now your V initial, what is your V initial? 10. Do you have a V final?
No, we don't.
What is this?
I thought that. Wait, I'm confused.
Okay, if you consider this scenario, ne? Only this scenario from B to D, it means you're gonna have 2 points. That's why I emphasize that you must always consider scenario by scenario. Let's say, for instance, from B to D, you're gonna have initial and you're gonna have final. So your initial is here. This is your initial. At your initial, velocity initial was 10 meters per second. Rendani, do you agree with that?
Yes, sir.
Do you agree that the velocity final at this point was minus 10 meters per second?
Yes.
So you do have velocity initial and velocity final, and also change in time.
You know what's confusing me, right? Is that sometimes maybe you say, yes, you do have like velocity final and it's 10, negative 10, right? And the teachers will tell you that no one ever told you that the object stopped at that point.
No one said the object stopped at that point.
Yes.
Ah,
So
even if nobody said so.
Yes.
But if you are looking for, because we are looking for acceleration, right?
Mm.
Even if an object continued in whatever kind of movement it continued with. In this question, we were told that the motion ended there. Or let me just say, that's what we were given. So we're only going to calculate what we have been asked, because they said between B and D. I'm not going to worry about whatever that happens after that. I'm only going to worry about what I've been asked, which is finding the acceleration between B and D. I'm not going to worry about what's happening between A and B. That's why I said initially that forget about scenario A, B. It has nothing to do with our equation. And again, I'm saying forget about anything that is happening beyond D. Nobody cares. I don't care. You shouldn't care. All that you have to care for is what is happening between B and D. And according to what is there on the graph, your V initial is 10 at that point. And then at point D, your velocity final, that's what I consider final, it's going to be minus 10. Are you still confused?
No, I'm not.
Okay. So we have V final, which is minus 10. We have
Sir?
V in it, yes.
Okay, can I please be dismissed? I want to study for maths.
Okay, but let's just get the answer for this one quickly. Then you will go. Acceleration, and then change in time, we got 4. If you take 10 to the other side, you're going to have minus 10, which is equals to A times 4. If you divide by 4, minus 10, it will be minus 20. So minus 20 divided by minus 4, it will give you 5.
Why did we put -4? Just to get rid of the negative sign?
Nah, I made a mistake. Sorry, it's actually a 4. You are right.
It's going to be -5.
-5, yeah. So do you see that it's the same as this one?
Yes.
So you can choose whether you want to use the graphical approach or the equations of motion. But if you're given a graph as a belief, it's much easier to just use either the slope of the graph or the area under the graph for a given portion of time. Are we all together? So Rendani, I think you can excuse yourself. I'm not gonna do a lot. I'm just gonna do maybe these few questions, then I will be done. So I think it will be easy for you to catch up next week.
Yes.
Okay, so yeah, good luck with your test tomorrow.
Thank you. Bye.
Bye. Okay, Kumisa, are you still there?
Yes, sir.
Did you understand?
Yes. Yes, sir.
So in the exam, you can choose whether you want to use the graphical approach or the equation of motion. But it is much easier to use the graphical approach if you have been given a graph. Are we all together?
Yes, sir.
Okay, perfect. Now, let us do question 5.2. Elena has to walk to shops to buy bread. After walking 200 meters, he realizes that he does not have enough money. He goes back home. It took him 4 minutes from the time he began walking until he returned to the house. Okay, I'm gonna give you, okay, no, I don't need to give you time to do this one. They're saying determine the learner's displacement. Kumisa, what is the learner's displacement in this case?
— 200 meters.
Unfortunately, the learner's displacement is 0. 0 meters. Because this is what they are saying. Okay, this is 5.2. If 5.2.1, they are saying the learner, this is home. They went out to buy bread and they walked 200 meters. This is the shop. From there, this is the first motion. The second motion, it traveled from the shop back to home. Now the change in displacement, it is the final position minus the initial position. Okay, this person didn't go anywhere. They went to the shop, but they came back to the same point. So if they came back to the same point, let's say if you draw a Cartesian plane and this is your reference point. If I move westwards, when I'm here, my displacement will be 200. But if I decide to come back, I'm coming back to 0. So my displacement, my final displacement is 0 minus my initial is 0. It doesn't matter where I went, but if I came back to the same position, my displacement is 0. But let's say, for instance, if I'm coming back from the shop, then I traveled from the shop, say about 100 meters from the shop to this point. If they ask for the displacement, my displacement will be the final position minus the initial position. So my final position was going to be 100 meters. So this was going to be the displacement, if that was the case. But if I come back to the same position, the displacement, unfortunately, will be 0. Kumisa, do you get that?
Yes, sir.
Okay, perfect. And then let's see the next question. Differentiate between the average speed and the average velocity. Or let's just say, what is the difference? What is the difference between speed and velocity? What is the difference between speed and velocity? Kumisa. .1.2. Velocity is the change in displacement or position over time, and speed is the change in distance over time. So there's a difference. When you're talking about velocity, you're talking about a vector. Therefore, velocity is the change in displacement. Displacement is also a vector. But when you're talking about a speed, speed is a scalar. So the speed is the change in distance. Distance is also a scalar. Okay, now let us do the last question. They are saying calculate the learner's average speed. The learner's average speed. So Tumisa, I'm going to give you 2 minutes to calculate the learner's average speed, because it took him 4 minutes from the time he began walking until he returned. It took him 4 minutes. So what was his average speed? I'm going to give you 2 minutes. Two minutes. 2 minutes. Question 5.3, 2.3, 2 minutes. Two minutes. This is easy.
I think the answer is 0.
The answer is 0.
Yes, sir.
Okay. Unfortunately, it is not 0. But I see what I see where you are coming from. I see why you're saying 0. It's 0. The velocity, you are right. It's called 0. I agree with you. Velocity. Now we are talking about the speed. The speed can be 0. The velocity is 0 because the change in position was 0. So the change in position divided by 4 minutes, it gave you 0. But the speed equals the change in distance, or let's just say the distance divided by change in time. The distance traveled for the entire trip was 200 meters going to the shop, plus another 200 coming back. Divided by the change in time, it is 4 minutes times 60, because I have to convert minutes into seconds. So this gave me 400 over 4 times 60 will give you 240, I think. Did you get 240, Kumisa?
Yes, sir.
Okay, so if you got 240, so what are you going to get? What is your final answer?
One comma 667.
1,667 meters per second. Okay, we just got the answer. So I just want to emphasize once again, there's a difference between velocity and speed. If I travel all around and round and round and round and round and round, then come back to that position. If I have traveled, say, 500 meters and then came back to that position, if the distance between the final and the initial, for instance, is just 3 meters, it means the displacement, which is a vector, is 3 meters, but the distance is 500 meters. So in order for me to calculate the velocity, I'm just going to say 3 meters divided by the amount of time it took me to come back to that point. And then if I were to calculate the speed, it was going to be 500, which is the distance, divided by the change in time, the total time I have used. There's a difference between velocity and speed. And the difference is that with velocity, or let me say with displacement, we don't care about your path. We don't care about where you went and what you did and wara and all that. What we care about is where you have ended. That's what vectors are all about. Your final position. But with scalars, we are going to calculate the distance of your entire path, wherever you went, over that specific time. So that is the difference between speed and velocity. So we have come to the end of our lesson. Our next lesson will be next week, Tuesday. So next week, Tuesday, I'm gonna be teaching instantaneous velocity. And we also gonna do fewer examples and graphical examples as well. Next week, instantaneous velocity. And then from there, we will be done with the chapter of displacement, velocity, and acceleration. Then from there, the last chapter that I will try to squeeze in maybe the following week will be potential energy and kinetic energy. We're going to do the last chapter, which is potential energy and kinetic energy. Then from there, we're going to hit revisions and papers. From there, we're going to be doing revisions and papers throughout physics and chemistry. Then we'll make sure that before you write the exams, at least we would have done about 3 papers. Then you'll be ready. Okay, I'll see you Next week, Tuesday.
Yes, sir.
All right. Cheers.
Sure.
Now, for those who are on TikTok, I want to start doing lessons on TikTok where I will also invite people to join the live. This Saturday, I'm gonna do a maths lesson for everyone. I'm gonna do a maths lesson for everyone who is doing grade 10. So I'm gonna do grade 10 on Saturday. Grade 10 on Saturday. Saturday around 12. Try to do it around 12. Okay, I'll see you guys on Saturday for maths. Maths grade 10 on Saturday. I'm done with the live. Thank you so much for all the people who subscribe to our channel. Thank you so much for everyone who liked. Thank you so much. I can see the new followers. I'll see you guys on Saturday.